Every day, millions of AA batteries are removed from remotes, computer mice, toys, and clocks, and most of them end up in household trash. They're small, cheap, and convenient, which is exactly why they're often overlooked. But AA batteries don't disappear when thrown away. Over time, they leak chemicals that pollute soil and water, and when handled improperly, they also contribute to greenhouse gas emissions. What many people don't realize is that a large number of these batteries aren't truly dead. They simply no longer provide enough power for a device at that moment. And that's where I feel a personal responsibility. Instead of throwing them away, I want to show practical ways to revive AA batteries using low-cost, simple, and effective methods, allowing them to be reused multiple times. The goal isn't to make old batteries new, but to extend their lifespan, reduce waste, save money, and ease the environmental burden. Sometimes, protecting the environment starts not with big promises, but with using one small battery just a little longer. To build trust before we begin, I won't rely on assumptions or explanations alone. I'll use a voltage meter to test two AA batteries side by side, one that's still working normally, and another that has just been removed from a wall clock after running out of power. The readings on the meter will clearly show the difference, so we're working with real numbers, not guesses. From there, every next step is based on clear, measurable results that anyone can verify. Completely different from the previous AA battery, this one shows no voltage at all when tested with the meter. The display reads 0, meaning the energy is fully depleted. This is a battery that was just removed from a wall clock and considered dead in normal use. The measurement is clear and straightforward, leaving no room for guesswork or assumptions. At this point, I believe you have enough evidence to feel confident in this testing process. And now, with the data clearly laid out, we can move forward and begin the repair right away. In the first step, cleaning the rust on the outside of the battery is not just cosmetic. This process serves two clear purposes. The first is cleaning. Rust and oxidation reduce electrical contact, preventing the battery from delivering power efficiently. Using sandpaper with a bit of multi-purpose oil removes this barrier and restores a cleaner metal surface. The second purpose is stimulating the positive and negative terminals. Gentle abrasion helps reactivate the contact areas, improving conductivity and preparing the battery for the recovery step that follows. This may look simple, but it's a foundational step that shouldn't be rushed. In a scientific article I once read by Professor William, what truly caught my attention wasn't complex equipment or expensive technology, but two very familiar everyday items, lemon and salt. At first, it sounds almost too simple to be believable, but when viewed through a scientific lens, the combination actually makes a lot of sense. Lemon contains natural acid, which is known for its ability to interact with metal surfaces affected by oxidation over time. In AA batteries, this oxidation layer is one of the key reasons electrical conductivity drops, even when the battery hasn't completely lost its internal potential. The mild acid from lemon helps weaken that barrier, allowing the contact surface to open up again. Salt plays a different role. Chemically, salt acts as an electrolyte, helping improve electrical conductivity under suitable conditions. When combined with lemon, it supports more stable surface-level reactions. According to Professor's analysis, this interaction can help reactivate weakened contact areas on AA batteries, creating a chance to extend their usable life instead of discarding them immediately. And once everything is properly prepared, there's nothing more to do at this stage. We simply wait about 30 minutes to allow the battery enough time to fully recover before moving on to the next steps. All right, that step is complete. However, there's no need to test a battery just yet. The first thing we should do is clean it once more. This helps extend a battery's lifespan and is especially important after using the previous method. If the surface isn't cleaned right away, moisture can remain and lead to rust forming again. Proper cleaning at this stage helps keep the battery stable and usable for a longer time. With the cleaning finished, before installing the battery back into the device, I'll run one final check using a voltage meter to make sure the battery is stable and ready for use. At this point, you can probably see that restoring an AA battery isn't just about making it work again. What matters more is how we choose to see the value of small, everyday items. A battery that seems completely drained, when handled properly and at the right moment, can often continue to serve its purpose for several more cycles. For me, this process isn't only about saving money or satisfying technical curiosity. It's a gentle reminder that many things we throw away are discarded too early, not because they're truly useless, but because we don't take a little extra time to understand them. AA batteries are just a small example, but behind them is a much bigger story about waste, the environment, and our daily consumption habits. By extending the life of a single battery, we're not just reducing one piece of hazardous waste. We're also lowering the demand for new production, conserving raw materials, and easing pressure on the environment. One reused battery may not change the world overnight, but thousands or millions of them absolutely can. If you stayed with me until the end, I hope you've gained more than just a tip. I hope you've seen an approach, one that values patience, understanding, and responsibility in the things we use every day. Sometimes, protecting the environment doesn't start with grand gestures, but with something as simple as giving a small battery a second chance. Over time, those small choices add up to something much bigger.